Given that theta is measured in radians, prove from first principles that the derivative of cos is minus sine. We may assume the formula for cos A plus B, and that as h tends towards 0, sine h over h tends towards 1, and cos h minus 1 over h tends towards 0. So, first principles. So we look in our formula booklet and remind ourselves of the formula for that, which is this. So in our case, the function is cos. So our formula will be the limit as h tends towards 0 of cos x plus h minus cos of x all over h. So I'm just substituting my cos instead of the function. Next, it says I can assume the formula for cos A plus B. So again, we can look at that in our formula booklet. That is going to allow me to expand the cos x plus h, where x is the A and h is the B. So if we do that, we will get cos x cos h minus sine x sine h. So this is me using the formula in the formula booklet to turn the cos x plus h into the cos x cos h minus sine x sine h. I've then still got the minus cos x, and all of that still needs to be divided by h, and we still need to take the limit as h tends towards 0. Right, the next thing I'm going to do is I'm going to group up my cos x terms. So let's group those up. So let me rewrite this as the limit as h tends towards 0 of cos x cos h minus the cos x. Like I say, we're just grouping those two terms together there. And then we've got the minus sine x sine h divided by h. I'm now going to actually split this up into two separate limits, a cos limit and the sine limit, so that I can apply these two limits separately. So I'm going to rewrite this as the limit as h tends towards 0 of cos x cos h minus cos x over h. And then we've got the separate limit, so I've got a minus limit as h tends towards 0 of sine x sine h over h. So all I'm doing is writing this limit and this limit separately. Next, I can factorise this cos x outside, because the limit as h, me changing h, me making h become 0, doesn't affect the x at all. Only the h. So because of that, I can factorise that cos x outside. So all I've done there is I've taken the cos x from here and here, moved it on the outside, so that just leaves the cos h and a minus 1 and the h on the bottom. We'll do the same thing with the sine x. Factorise that sine x outside, because again that's not affected by the limit as h tends towards 0. And finally, we were told in the question that we could use these two limits. So this, I'm told in the question, is actually just tending towards 0. So I've got cos x times 0 minus sine x times this limit I was told in the question was 1. Cos x times 0 is 0, sine x, or minus sine x times 1 is minus sine x. And there we go, we have shown that when you differentiate cos, you end up with minus sine.